Hi guys, now we're gonna see how to start an analysis on Abaqus. We're gonna study the pipe system subjected to harmonic loading with the frequencies up to 50 Hz. For the geometry of the model, we choose 3D deformable wire planar with an approximate size of 7. Continue. We draw a line with 5 meters as a length, and then for the material it's steel, with a general density of 7,800. And elastic, the youngest metal is 200 gigapascal, and cushions ratio 0.3. Okay, now we create a pipe profile with a radius of 0.09 and a thickness of 0.02, thin walled formulation, and a beam section with the material steel previously defined and the pipe profile. And the section integration is done during the analysis. Okay, now we assign the section. There's no need to create a set for it. Done. Okay, and we assign the material orientation. We keep the default defined direction. Okay. Now create an instance on the assembly module dependent, and we define two sets: a left set for the left vertex of the pipe and a right one for the right vertex of the pipe. And now we define two steps. The first general static step and we toggle on the nonlinear geometry. We keep all the default values except the initial increment size. We put 0.1 as a value, and a third step, type linear perturbation for the frequencies extraction, and request 8 values for the eigen values. Okay, for the eigen frequencies. Okay, now for the first step we define the load, the actual loading. For the set right, we highlight to get sure. Continue with 4 meganewton along the first direction and nothing along the second and the third direction. Okay, it's shown here as it's shown. And for the boundary conditions, okay, the left side is clamped, so okay, and the second one is fixed for all rotations and translation except the first one. Okay, we add nothing for the second step. Here we request restart inputs, 1 for the step, the frequency step, and 10 increments, every 10 increments for the general static step. Now we save the model as a pipe. Yes, we create a job pipe Okay, we submit the job. Okay, in the model, regions of the part 1 have not been assigned the orientation. Okay, part property assign the orientation. Done. Okay, and still we have to define the mesh. Seed. Okay, seed part. See the edges. Then by number, we define 30 elements along the pipe, and the mesh element type. We choose the family pipe with a quadratic interpolation, a 3-node quadratic pipe in space, and now we mesh the part. It turns blue. Now we could submit the analysis. We monitor at the same time the process. This completed. Results. In the form structure, allow for multiple plot states. This is the node 2, node 1. Step frame. Okay, the first frequency 47.49, while the structure is subjected to frequencies up to 50 Hz, so it's prone to resonance. We should apply a higher loading for the structure to avoid resonance. Okay, let's check the other nodes. Okay, so we restart the analysis and try to increase clock given model. We apply loading, copy, model 2. Okay, and we're gonna add 2 steps. General static step. Okay, in the 4th step, type frequency. Okay, now for the 3rd step, we're gonna change the value of the applied loading from 4 to 8 milliNewton volt. Okay, and first of all, we need to edit the attributes. It's the most essential thing for restart analysis. We put here the name of the model, type model, and the step name from the last step 2. Okay, and for restart requests, same like for the first analysis. Okay, now create restart type. The job type is restart type. Okay, submit. Voilà. The the analysis starts from the end of the second step defined in the previous analysis. So from the third step, the first step defined in the second analysis, and here we have the total step time of 2 for the 2 general static steps defined in the whole model. And let's see now the results. We have for step 3, well, we have the first frequency 53. It's higher than the frequencies of the harmonic loading to which is subjected the pi, higher than 50. Now we are avoiding the resonance of this structure that might lead to failure. Okay, that's all about restarting an analysis in Abaqus from a previous analysis, already defined analysis. Thank you for your attention.